In this video, we're going to prove another theorem about Diophantine equations. If a and b are relatively prime positive integers, then their equation ax minus by equals c over the integers has infinitely many solutions. If you like watching videos where things are proved, theorems, postulates, corollaries, lemmas, subscribe to this channel, as that's all we do. No need to look elsewhere. Please subscribe to the channel, like the channel, and leave comments. I love reading your comments. How about we get right into the proof? First thing we know is that a and b are relatively prime integers. So, we're given, okay, let's not say given. Relative prime, let's say it right. A and b are relatively prime implies that the GCD of a and b is 1. And they're positive. A and b are positive and they're relatively prime. That means the GCD is 1. And clearly the GCD divides c. This one divides every number. Okay. So, since the GCD of AB divides C, that implies AX minus BY equals C has infinitely many solutions. But, infinitely many positive solutions, it should say. Infinitely many positive solutions. Okay. So, we know that there's infinitely many. Let x0, y0 be one of these infinitely many solutions. Then all the other solutions will be in a special form. Will be in the form of x equals x0. I probably should have written down the Diophantine equation in the proof, but I didn't. Maybe one should. Who knows? Now, let me just write it here. We know that ax minus by equals c is the same as ax plus negative by equals c. And we know that when an equation is written in this form and we have a solution like x0, all the other solutions will be in this form, where 1 is the GCD. That is, x is equal to x0 minus bt. And y is going to equal to y0 minus a over the GCD times t. That implies that y is equal to y0 minus at. Okay. Now, we want infinitely many solutions. So we want both of these to be positive. we want x0 minus bt to be positive, and we want y0 minus at to be positive. Well, this implies that x0 has to be bigger than bt. Now, b is positive, so this implies that x0 over b must be bigger than t, or t just needs to be less than x0 over b. Okay? This implies that y0 must be bigger than at. Since a is positive, then y0 over a has to be bigger than t, or t is less than x0 over a. Well, so we need t be less than x0 over b, and t is less than x0 over a. Well, of course I must have a couple of mistakes there. This should be y0, just like it was right here. And this should be y0 over a. Okay. Now, let S equal the min of x0 over b, comma, y0 over a. So, just choose t to be less than the min. Because if you want t to be less than 3 and you want t to be less than 5, then you let t be less than 3. Because if t is less than 3, that's true. And if t is less than 3, that's true. For example, if t is less than 4, then yeah, t is less than 5. But no. T is not less than 3. Not necessarily if t is less than 4. If t is less than 4, t can be 3.5. If they're both negative. If t is less than -2 and t is less than -5, you want to choose a t that's less than -5. Because you can be less than -2, you can be less than -2 and less than -5. But only over here are you less than -2 and less than -5. Same thing if one is positive. That's +2. If you're less than -2 and you're less than -5, they're both true only when x is less than the smaller one. So you choose t to be less than s, and you're guaranteed that this will be positive, and that will be positive. That would be positive. Okay, x, which is x0 minus bt, will be positive. This x, which is that, will be positive, and this y, which is that, will both be positive. So just choose s to be, so choose t, which is less than s. And that would complete the proof. Just basic definitions I use. Not even that many. I use the fact that the GCD of A and B equals 1 implies that it divides the C in their Diophantine equation, and relatively prime implies the GCD is 1. And then I use the fact that if you're giving a solution like x0 and y0, all other solutions are, like x and y, are in this form. They're in that form. Once again, if you like videos like this, subscribe to my channel. Every day I upload a new video. See you guys in the next video. Watch and learn.